What you going to show us today, Roy?
Well, this time I'm going to show how to find all of the fractions in the fraction key. And so in the directions on the front page, you'll notice that I start the math lesson and I divide them into three types of fractions called A, B, and C. And I've done a blowout of those here. In the type A fraction, the denominators have nothing to do with each other, so their product is used to make the common denominator. 2 does not go into 3, nor does 3 go into 2, so you must use 6. This shows the equivalent fractions. In the type B fraction, one of the numbers on the bottom of the fraction will go into the other number. Since 4 goes into 8, take advantage of that and use 8 as the common denominator. It works and usually saves the need to reduce answers at the end. And so since 4 goes into 8, we choose 8 as the common denominator. 1/4 becomes 2/8 by equivalent fractions. The 8 gets recopied into the answer, and the 2 and the 1 get added to make the final answer, 3/8 in this case. The type C fraction has numbers that have a relationship. You could use 24 as a common denominator, however, there is a smaller number that works that is common to both denominators, namely in this case 12. So 4 and 6 both go into 12, so we'll use that to our advantage and not have to deal with the 24. 1/4 became 3/12, 1/6 became 2/12. Now that we have all 12ths, we add the 3 and the 2 to make 5, in other words 5/12. These all happen to be the egg crate fractions that I talked about in the first tape, and so I'm going to do one more sample roll and show a sum with those. And so I'll just take 2 of these dice randomly, toss them, and here we have 1/6 plus 7/12. I didn't script that, it just came out randomly. I always tell the student to pick the simpler fraction and put it in front. In this case, 1/6 is easier to work with than 7/12. So I'm going to set these aside just for a second. Turn the page until I find the 1/6, and then scroll across the top of 1/6 until I get to the part where it combines with 7/12, and that's going to be right here. Now then, notice that 6 goes into 12, and so you should instantly notice that that was a type B fraction where one of the denominators goes into the other. This one did not have to change. 7/12 will remain 7/12. 6 times 2 makes 12, so 1 times 2 makes 2. We now have the equivalent fraction. Common denominators. We add the numerators, 2 plus 7 to make 9. This is a good example because this one needs to be reduced at the end. And so when that occurs in all the math problems, you'll show the reduction to lowest terms. 9 and 12 happen to have a common divisor 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. And so the final answer for 1/6 plus 7/12 is 3/4. And there's all of the detail and the so-called show your work that makes it come true. Now just to bring in other fractions that will occur, you can mix the dice, and this time I'm going to do a sum with an egg crate fraction and a non-egg crate fraction, and so I'll roll those, and I came up with a half plus 4/5. Now when you look at this section of the book, the first 11 pages, notice how it says ECF with ECF, egg crate fractions with egg crate fractions. This is obviously a non-egg crate fraction. And so I'm going to switch to the middle of the book, pages 12 to 30. Again, remembering that I want to choose the one that has the simplest fraction first, I'm going to look for sums, ECF with NECF, and find the half at the lead. And so I find that page. In this case it happens to be page 12, and there's the half sums, ECF with NECF. Now I just simply march along the fractions until I find the one that says 1/2 plus 4/5. And sure enough, there it is. Now this is going to have another feature that makes it a very valuable teaching problem, even though we just stumbled across it by coincidence. In the first case, notice that it's an A-type fraction. The denominators have nothing to do with each other. 2 does not go into 5, nor 5 into 2. So we'll use 10 as the common denominator. Making the equivalent fractions, we'll notice that 2 times 5 makes 10, so 1 times 5 makes 5. 5 times 2 makes 10, so 4 times 2 makes 8. So we've made our equivalent fractions 5/10 and 8/10. The denominator copies, 5 plus 8 is 13. That's an improper fraction, and so this is one that we'll get to change to its mixed number, 1 3/10. One more sample to do will be to take an ECF with an ECF. I meant to say non-ECF with non-ECF. And so I rolled, let's go 1/10 and 1/5. Okay, so I'll let you focus on that for a second. 1/10 plus 1/5. And in this case, the fifth is going to be the easier fraction than the 1/10. This takes us to the back of the book. The last 5 pages, pages 31 to 35, have all of the non-egg crate fractions with all of the non-egg crate fractions. And so there's a tenth and a fifth. It turns out that I put that one first, sorry. And then the 1/10 stayed 1/10. The 1/5 turns into 2/10. 1 plus 2 makes 3, 3/10. So now you can see how you march all the way through the book. And just one more thing to show quickly. Let's focus on here for a second. This just shows you that the sequence and the downloadable problems work for not only add and subtract, but also multiply and divide. So notice how you're having a half divided by a tenth? Everybody knows when you divide fractions, the second fraction gets flipped before you multiply. And you take advantage of top-bottom canceling whenever you can. 2 goes into 10 5 times, leaving the invisible 1, so 1 times 5 is 5, and 1 times 1 is 1. 5 over 1 becomes 5, therefore a half divided by 1/10 makes 5. And so if now we scan the whole page, you can see how generously we've gone to the trouble to make truly a complete key for these dice.